I decided to start up another little project here. This is actually going to turn into, hopefully, maybe like a mix between a Heimer and a touch probe. And this is kind of the first step for me. I'm trying to use a magnet, which you can see is chucked up here in the Jacobs chuck here, and then also a Hall effect sensor that is over off to the side. And kind of the idea is to be able to measure the magnetism or the flux and have it be accurate and repeatable without using any kind of contact or switch or anything like that. So most probes you see out there, Bloom uses more of an optical switch or optical type sensor. Renishaw has a couple different variations, but the majority of these types of probes and measurement devices are very, I guess, digital. When you come over and hit the part with the probe, then what that does is that breaks or makes a contact, and that's what tells the machine that, okay, an object's been touched. So with doing this type of method, it's more of an analog type method, but I think what I'm hoping for is that can lend itself to be able to start using it as more of a measurement device, not only just saying on or off, but then also being able to measure rotation and then also distance using the magnet. So I'll go a little bit more in depth of, I guess, what my plans are or what the idea is to accomplish this, but what I've done is I've set up the Tormach and I have a little chip here that I'm having drive the Tormach, and it's taking information from the Hall effect sensor over here and adjusting path pilot or stepping the machine based on the signal that it's getting from the magnet. So yeah, I'll in the next video here I'll cycle it a couple times. Now, the first video you're going to see is going to be, I guess, what I'm calling a far field test. I don't know if that's really the right terminology, but if you can imagine, these lines of flux in the magnet are going on both sides, this way and that way. So on this, I'm actually taking, I guess, the far end of the flux line and measuring that. The other test is I guess what I'm calling a near field test, and that's more based off the center magnetism. So as that flux comes around, you can actually measure it on this side or this side. Now, this side, the reason I'm testing it, because I'm not sure if it's going to be accurate enough. The flux as it comes off the magnet, and somebody could probably correct me if I'm wrong, I guess exponentially gets weaker and weaker. So that variation, or that distance traveled versus the variation, is a lot less. So in the near field test, everything is very, very compact, and I mean, it's like over 30,000 span. I can like chop it up into like 9,000 increments is what I'm seeing. Now, I don't know if it's all linear or what, but it's pretty crazy when, for what it is. I mean, it's probably a $3 sensor and maybe a 50-cent magnet or something like that, but it's pretty remarkable on, I guess, some of the stuff I'm seeing, so I just thought I'd share it. So this is the far field test, I guess what I'm calling it, and what you're going to see is the machine is going to wrap it over until it starts to see magnetism. As soon as it starts to see magnetism, it's going to stop its rapid, and then it's going to switch over into a 1,000 step mode increment, and it's going to step in until it gets to about 3,000s, and then after that it will switch over into tenths and then dial into 0. I guess I just have the stop point set at at X0 right now. That's the axis I'm working with right now. So yeah, what I'll do is I'll go ahead and reset up the test here, and I think we're pretty much ready to go. I do have a couple timers and delays in there to give myself time to adjust here, but this is it. So that was the entire cycle. Now you can see how far away that magnet is from the sensor. Now I'm getting around a couple tenths repeatability, at least on the what the PathPilot DRO was telling me. My indicator, I only have a thousandths indicator, so it's kind of hard to reliably say that for sure. But that is pretty good, I think, for this far field test. And I'll show you PathPilot here and let you kind of see, I guess, in a wide angle view to see exactly what it's doing. Okay, I think I have everything in frame here. So what I will do is restart the test here, and I just kind of have it set up. So it's in continuous. I'm going to reset the microcontroller so it starts up the next cycle. So this is what I'm getting. The first thing you'll see is rapid, and then it'll go down into 1,000th increments. And it'll step till, I'm seeing like 3 or 4 thousandths, but it's all software adjustable. And then that one was dead on, at least what PathPilot's saying. I can't really verify that yet, but yeah. So I'll go ahead and just restart it one more time. Let you check it out. Alright, I have like a 5-second delay in there, just to give you time to... So I think it's kind of stopping too soon, but a lot of that is based off how fast your rapid is, or your jog is, I guess. So that was 3/10 right there, which that's not bad for the far field. Obviously, when I get to the near field test, I mean, it's always within a tenth that I can measure, I guess, with this setup. So I'll switch over to that. Okay, so this is, I guess, the near field test. Now, I kind of have this script running a little bit differently. I have it so as soon as the machine, or I guess the chip, detects that the magnet is going away from center, it'll automatically step and try and find center again. So what I'll do is I'm going to use the jog shuttle here to step it away from the X position, and then you're going to see it try and go back to 0 all the time. So that's what you'll see. So that's usually, I'm getting like within a tenth again, but it's like I said, it's almost impossible to verify for me right now. Or if I wanted to, I could do a little bit farther. Well, that didn't work. Oh, I know why, because I'm outside of the range. So that's one of the drawbacks of this. Let's see if I can get inside the range. Oh, there it goes. So we're talking about 20 thousandths window, or I guess 40 thousandths on either side when you add it together. So there it's trying to step back down to 0. So that's it. So it's all. What I'll do is I'll show you some of the ideas and maybe the 3D model that I'm trying to come up with, and how this is actually going to maybe tie into a Heimer type measurement device and/or possibly a touch probe, just all depending on where it goes. So this is kind of my first idea on this, I guess, how it's going to be set up. What I'm thinking about is having kind of an array of Hall effect sensors that will come over and, I guess, detect the center of each magnet here, and what that will do is anytime there is any kind of shift in the magnet, that Hall effect for that axis, that Hall effect sensor will detect it. Now the other thing that you're going to see is a spring. That's just for a spring return. Again, I'm not sure how, this is the final design here, but it's kind of just the start of the idea here. And then you're going to see this screw sticking out the bottom here. That is actually going to be my probe for testing. One of the benefits is that everything is software driven. and software calibrated, the run out and all that really isn't that big of an issue, because if what I'll do is I'll be able to calibrate that probe based off of a known, and then that will be the run out, and I'll be able to set points based off that probe. So that's pretty much the gist of the idea. I'm not sure how much more I'm going to do to this. Obviously, it's going to be more than this, and I'll keep you updated.